Let's work on our helper method for energy and get done with the JiEnergy system. Hello everyone, this is Ali Reza. Welcome to the Mentor Code Lab. In this video, we will add a helper method that will help us to simulate and spread and do transaction of energies. It is much simpler than what we had for the fluids because we don't carry out the complexity of fluid and we are much simpler here. So we say it is called energy helper. Here we want a public static long simulate insertion. For simulate insertion, we need an energy storage. Call the storage the amount, the transaction. Let's call it outer. Let's compare it to what we have in GFluid because the signatures will be close to each other. So as you see, we don't have the is empty. Actually, we can use that. Then we don't need to handle the transfers like this. We don't need to do that. We don't need any of that. Here, simulate insertion using outer. We are using a variant here. We don't need that. Okay, I was looking at the amount. Let's take it to the second monitor. In here, I don't need the amount. Actually, all we are doing here, we say long amount equals to 0. Then we will try a transaction. We call it transaction that equals to outer dot open nested. Then we say amount equals to the storage dot insert. We don't have any variant here, thankfully. We go with long dot max value and then the transaction. We abort the transaction and finally at the end we return the amount. As simple as that. We have an overload for this that will not accept any transaction. It's almost identical. The only thing that is changing is that transactions equals to transaction.openOuter. That's that. Then I want to for the simulate extraction. So simulate extraction. This time we go with extract. And again, that's that. Now, thankfully, as I said, we are much simpler compared to this. We don't need to check if we are the same energy because energy is always energy. All we are needing is to check if we are full, if we are empty, things like that. But let me check my notes first. So we simulate the insertion and then we go for the spread here and get energy storage, get all energy storages. That's it. So let's add those few methods from the fluid system. Going from top, we have is empty. And thankfully, we don't have any different things. So we will say public static that returns a boolean. We call is empty. All we are accepting is an energy storage. We call it storage. And all we will return, hopefully it's smart enough. It's not. We say storage dot get amount equals to 0. As I said, it's much simpler. Public static boolean. What did I call it? Is full. Let me double check. Is a storage full. So instead of is empty, is storage full. Again, we need a storage. All we are returning, we are checking if we are greater than or equal to the not long max value, god damn it, the storage dot get capacity. Okay, much simpler, isn't it? Now can accept public static boolean can accept. Here we don't have any payload or I don't know stack. We just need the storage and int amount. All we are checking is that return the amount that we send in is smaller or equal to storage dot get amount plus. Let me double check. No, it's the other way around. The amount that we already have plus the amount that we want to send in will end up to be smaller or equal than the capacity. Then we want to get a storage. So I think I have it in my notes from now. Let's take a look. No, we just have the spread thing. I forgot. So no, I have it. Let's take a look at my notes. And if possible, I want to copy paste to reduce the time, although we have the time. So here, get energy storage and get all the storages. So we will say that we want to return a public static that returns an energy storage, and we call it get storage that accept a word, a block pause, a set of block pause, and we call it blacklist, and finally a direction. Now I will move the direction back, direction. All we want to do is say that we want a block pause and we say adjacent pause equals to pause dot offset on the direction. If the blacklist is not null, yeah, you very smart, and blacklist contains the block pause, we return null. Otherwise, we say return the energy storage dot sided dot find on the word on the pause with the direction dot get opposite. Okay, same deal that we had inside the fluid storage, but we don't need to deal with a loop, an iterator, none of that. So public static that returns a list of the energy storage. We call it get all storages in the world, block pause, direction, and blacklist. And actually, we don't need the direction anymore here. So here we say that we have a list of energy storages. Then we want to loop through the direction.values.for. We call it direction. Here we do exactly the same thing. So we get the adjacent block pause. Then we want the energy storage. So we get that. We call energy storage. We call it the storage equals to that. Then we check if the energy storage, we call it the storage. Okay. If the storage does not equal null, we say storages.add storage, and at the end of the loop, we return storages. Finally, the spread methods. Now, the same deal is happening here, but thankfully, as I said, it's 10 times simpler. So we say public void spread. All we want is a block entity. We call it block entity. We don't need the word pause or anything else. All we want is an energy storage. We call it the storage. A boolean that we say equal amount, and finally a set of block pause that is the blacklist. We will say a list of energy storages. We call it the storages. We get everything around it ourselves. Then we say if storages dot is empty, simply return. We don't have anything else to do. Then we want to do transaction. And here's the thing. In my notes, I start with the transaction. Then I do anything that is possible for any adjacent storage. Then I will set the amount. And it is wrong. Why am I plussing? We're increasing ourselves. Okay. Then we commit the transaction. And if we need to, we set the block entity. And then I connect the try transaction. In case of fluids, we couldn't do this because this part would be nested for loops and ugly stuff. But in this case, I think we can handle all of that in one go. So try transaction open outer. Here we say long current equals to get amount. Long extractable equals to simulate extraction on the storage. Simple as that. Then we say long total inserted equals to be 0 right now. Another long final amount equals to, if we are using equal amount, no, that's not. It will be total, it will be extractable divided by the storages dot size. Other way, it's extractable. Then we go for a for loop and we go with energy storage inside the storages. Can I call it a storage? No, because I'm using a storage somewhere. Okay, this is adjacent storage and we want to do the transaction. So long insertable equals to the energy storage that we call adjacent storage dot insert the amount that we want, final amount and the transaction. Then we say total inserted plus equals to inserted. After the for loop, let me go back to my notes on the fluid because right now, believe it or not, we bypassed this and we don't have that for loop on top. So we want to say if the total inserted is greater than 0, we want to extract it from our storage and that. Okay, so just like that, here we have what's wrong with you. Oh, we have the transaction outer. Okay, I can go with inner, can't I? Open, no. Okay, I will go with the transaction. Don't I have access to that? Let's call this inner transaction dot open nested. Here we use the inner and we don't have the variant anymore. So that's that. We commit the transaction, we come out. If the current is not equal to storage dot get amount, the rest is history. Now that we have that, I will just add few more overloads in fluid helper. We have these overloads, so let's just copy them and finish this thing faster. Now here we will have the blacklist and we don't have a storage fluid like that. I need to move things around on that one. So I have this guy inside all of these here and here, and that would be it. Finally, I will take this guy and move it there. I will do the same here. I will get the blacklist, move it to the end. And funny enough, we have our overloads. So we have an overload that accepts a block entity, a storage, and a blacklist, and we use equal amount there. Then we have a block entity and a storage and equal amount, so we don't have any blacklist. And finally, we are equal amount without any blacklist. And that is our energy helper. Funny, that is the end of our energy library. If you like these videos, please subscribe to the channel, hit the like button, and turn on that bell so that when I publish a new video, you will get informed. Have fun, everyone. Bye.